The pager went off at 02:13 a.m. I remember staring at the alert for a few seconds, trying to process it. Critical, API error rate above 65% across all regions. At the same time, Slack was already lighting up. The incident channel had 3 messages in under 10 seconds. I opened Grafana immediately. Request success rate had dropped off a cliff. It wasn't gradual, it was a vertical line straight down. Latency graphs were flat, almost suspiciously clean, but throughput had collapsed by more than half. CloudWatch alarms were firing in batches. Kubernetes dashboards showed pods running, CPU normal, memory normal. Nothing looked overloaded. Nothing looked like it was crashing. But users were clearly not getting through. I hadn't even had coffee yet, and already it felt like something fundamental had just broken. We were running a multi-tenant fintech platform on AWS. The core application stack was deployed on EKS across 3 availability zones, fronted by an application load balancer. Traffic flowed through AWS WAF at the edge, then into the ALB, and from there into Kubernetes services exposed via ingress. At peak, we handled around 15,000 requests per second. The back-end services were a mix of Node.js and Go microservices, backed by PostgreSQL on RDS and Redis for caching. Our CI/CD pipeline was GitHub Actions triggering Argo CD deployments. Infrastructure was managed with Terraform. We had pretty strong observability, at least on paper. Security-wise, we had multiple layers. Security groups at the VPC level, network policies inside Kubernetes, and AWS WAF rules at the edge. Over time, those layers had grown more complex. Everything was designed for high availability and fault tolerance. At least, that was the assumption. Users were reporting failed payments almost immediately. The support team escalated that transactions were timing out, not explicitly failing. That was an important detail. From the dashboards, error rates were high, but not uniform. Health check endpoints were mostly green. Internal service-to-service communication looked fine based on traces. Externally, though, the picture was messy. The ALB metrics showed a spike in 502 and 504 errors, but the pods behind those endpoints were healthy. No restarts, no crashes. One thing stood out. Incoming request count at the ALB had dropped significantly. It was like a portion of traffic was being silently filtered before even reaching the cluster. At first glance, it didn't look like a typical application failure. Something was blocking traffic, but not completely. That partial failure made it harder to reason about. By 02:18 a.m., 2 other engineers had joined the incident channel. One focused on application logs, the other on infrastructure. I started with the load balancer. I checked target group health. Then I checked access logs. That's where things started to feel off. There were way fewer entries than expected. I pulled up WAF metrics next. Blocked requests had spiked sharply around 02:12 a.m., just before the alerts triggered. At that point, I had a working hypothesis. Meanwhile, someone else pointed out that internal synthetic checks from within the VPC were passing. External synthetic monitoring, though, was failing intermittently. Then came a misleading signal. One of the engineers noticed a recent deployment about 10 minutes before the incident, a routine back-end update. We rolled it back immediately. Nothing changed. Error rates stayed high. Traffic stayed suppressed. That was a dead end. At this point, we pulled in our security engineer. He asked, "Did anyone change WAF rules tonight?" Someone mentioned a Terraform apply that had run earlier. We pulled the plan. There it was, a modification to a WAF rule group. The rule was meant to block suspicious IPs, but the diff showed something subtle. The allowed IP set had been modified. A CIDR block was truncated, just a small change. The updated rule combined an IP whitelist with a rate-based rule, but instead of an override, they were evaluated in sequence. Whitelisted IPs were still hitting the rate thresholds. And because our traffic patterns were bursty, especially during certain operations, legitimate client IPs were hitting those thresholds. They were being aggressively blocked. We had 2 options: roll back the WAF configuration entirely or patch the rule. Given the impact, we chose rollback, faster and lower risk. Within about 2 minutes, WF blocked request metrics started dropping. ALB request counts began to recover. Error rates followed shortly after. Success rates climbed back above 95%. Only after confirming stability across multiple regions did we formally close the incident. Total recovery time from alert to resolution was around 25 minutes. What actually failed was not just a firewall rule. It was how we managed and validated edge security changes. Our detection was weaker than we thought. We had alerts for error rates and latency, but nothing specifically for abnormal spikes in WAF blocks. We also lost time chasing the application deployment. Edge components like WAF and firewalls are part of your production system. They deserve the same level of testing and observability as application code. Every security change should have a blast radius analysis. Even small CIDR modifications can have wide-reaching effects in high-scale systems. Rule evaluation order must be explicitly tested. Correlation matters. Being able to see WAF, load balancer, and service metrics together would have reduced our time to root cause. Observability must include security layers. Automation is only as safe as the assumptions behind it. Infrastructure as code does not eliminate risk. It just changes where the risk lives. I still think about how quiet the system looked from the inside, while the outside world was effectively cut off. Sometimes, the most critical failures happen at the boundaries.